Hello everyone for the viewer who watch this video. So I am Rachman Widyadhana with number 135230004. We have presented my paper on algorithm strategies course IF2211. So my title is a hybrid regex-based pre-processing and LSTM neural network approach for sentiment analysis of Tokopedia reviews. So the data set I get is from the Tokopedia review sentiment analysis contains two data. The first one is train CSV, the labeled data, of course, for you to use to train our models, contains ID, review stars, and review status, or the sentiments or the labels of the review given. And then the test CSV, the unlabeled data, of course, to evaluate our model only contains ID and review. So for the overview of my presentation now is contents in the notebook content here. So the first one is initial dataset exploration, exploratory data analysis, the main topic text pre-processing with regex, and then modeling with LSTM, and the last one is submission. So for the initial data set exploration, of course, we import the important library. So the main one is TensorFlow, which is importing keras for the LSTM model, and then the import RE or regex for from the Python library to pre-processing. So we load our dataset and then view the samples of the reviews here. So it's just not clean. There are some emojis, some punctuation, some numbers that so dirty and make the model hard to understand the data. So we need to clean them. Now we check first the dataset size. So when comparing the train and test sets, we found some fraction and it's big, and the train set is 88%, whereas the test set is only 11%. Now we also need to know the target distribution of train. So the good and bad is kind of balanced because not uh, big difference of the fraction, but the neutral is so far away from the two other, so it yielding an insight that many customers is expressing their emotion more than just giving the neutral review. So for more insights from the reviews, there are some word cloud visualization, but here we get the insight, which is some common words is just flooding the data sets that make the model confused. So we need to remove them also, that called stop words. So here the main topic of my presentation. So this is the text processing pre-processing with the regular expression. So the first one is we remove the literal of tabs, new lines, and escapes. And then after that we delete mention hashtag and URL, and then rather than removing the emoji, we convert them first to get more context of them, and then we delete the non-SJ and punctuation and numbers after that. Also we remove single character words so that it's not flooding the models too with single words that not necessarily give context, and then we remove extra white space. After that, lastly we lowercase them. Now the stopwatch I have mentioned before is from the Indonesian because the dataset is from Indonesia, and then we add yang and nya that so common in many daily sentences in Indonesia. So we get the cleaning here, and then we clean also the stopwatch and tokenize it. Tokenization is important for NLP, natural language pre-processing machine learning model, because it gives the dictionary of the words that occur in the datasets. So give the model more context of it. So as for instance or for example, so in data set here. The initial is there are punctuation emojis after the processing. There are no more emojis, punctuation, and so on. But also we get the embedded vectors here. After that, we pad the sequences to insert uniform length for batch processing in the neural networks, and then the data is split to entertaining and validation sets with proper label encoding for model training and evaluation. So now we get the modeling in here. So the methods are there are two main methods. First one is baseline LSTM without attention, and then we add attention to it so that it gets more complex relationship. So for the first one is the baseline model follows a straightforward sequential architecture designed for text classification. It begins with an embedding layer that converts word indices to 128-dimensional dense layers, dense, dense vectors, creating a meaningful representation of the vocabulary, as I mentioned before. So, and then the model employs two LSTM layers in this succession and with return sequences through, process the entire sequence and passes all hidden states to the next layer. This final state captures all context from the input sequence. Then after that, pass through a dense layer with ReLU activation for feature transformation before the final softmax layer produce probability distribution over the three classes. For the attention version one, the attention version, we add multi-head attention mechanism to improve model ability to focus on relevant parts of the input sequence. So here, after the initial embedding layer, the architecture added the multi-head attention. So here we can see the multi-head attention layers. The This method enables the model to capture complex relationships and dependencies across different positions in the sequence. The attention mechanism help the model weigh the importance of different words of phrases when making the final classification problem. So the with the attention version, it can handle more insights or context from the data sets. Now we evaluate our models to get the meaningful important insight for the sentiment analysis. So the first one is without attention is perform not good and kind of cannot kind of can be said as bad because it just all into the good label. So the all others just predicted as good. So the model cannot difference and confuse about the words that are common in some text and then just predicted as good because the good before we when we check it has the most fraction of the data set and then the model just thought, oh, all right, we predict just all of them because we get half right or 55% right from just all in prediction. Now with attention, it performs more far from the baseline because now the bad label is now get the huge improvement from the 1000 prediction to only 2000 left from the wrong prediction. Now it correctly predict almost 80% of the bad label, and he got some prediction of the neutral. Now this is a huge difference from the two methods. In comparison, the model with attention readers cross-class confusion for bad and good sentiments by over 70%, yet both architectures failed to capture natural sentiment. Additional techniques such as class rebalancing or more sophisticated feature extraction will be required to address this remaining information limitation. So for the neutral, it's kind of hard because it has so little fraction of the dataset, so the model cannot get no information or context for it. Now for the last section is the summation for the test dataset. Now we just predict with our model with attention one, and here is the sum of the example of the prediction. Now we submit and then get the F1 score from the competition. So that's the last explanation for my presentation. Thank you for listening and watching till the end of this video. See you again.